Hi viewer, welcome back to my YouTube channel Remote Sensing GIS Home. So hope you are doing well. Today we are going to learn about how to calculate land surface temperature or how to estimate spatial temporal changes of land surface temperature over a region. Okay, so in this tutorial we will cover about the dataset, how to download the data, and the how to build a model to automatically calculate the land surface temperature. Okay, so let's start the tutorial. So today topic is a spatiotemporal analysis of land surface temperature day and night using MODIS version 6 product. Okay, so this video will be cover enter the topic and you have know about the data type, data details, and so at first we have want to know how to download the MODIS version 6 product data. Okay, then go to how to calculate daily basis daytime land surface temperature automatically. Okay, then go to how to calculate daily basis night time land surface temperature automatically. Okay, we have create a model, enter the process the data automatically. Again go to the about the collection of the data. Before start the process, you have to know what is the MODIS data, and they are the details of the data. Okay, so details of the data, the collection of the data is Terra MODIS, the temporal resolution of the data is daily. Okay, so the MODIS version 6 land surface temperature provided in daily basis. Okay, temporal extent, that means since the data will be provided from 24th February 2022 present date. Okay, spatial extent, the data will be covered globally, and the coordinate system used in the data is sinusoidal. Okay, datum nothing used, and the file format of the raw data is HDF or EOS. Okay, and geographic dimension of the data is 1200 kilometer into 1200 kilometer. Okay, then learn about the granular details. Granular means a data that have a more layer. Okay, so in the MODIS data have a total layer in 12. The number of science dataset layer is 12. Okay, and the column and row is 1200 into 1200, and the pixel size is 1000 meter or 1 kilometer. Okay, again the layer description. So entire layer is cover the granular 12 layer, and the we have learn about the land surface temperature day and the night. Okay, so here is the description day land surface temperature. The units in the data provided in the Kelvin format. Okay, and data type is 16-bit unsigned integer. Integer value, field value 0, no data value is nothing, and the valid range, that means the Kelvin data provided from 7500 to 65535. Okay, because the data is 16-bit. Okay, the scale factor is 0.02. so same adjective the land surface temperature of the daytime as in night time, here also the same also. Okay, the description, the data cover the night time land surface temperature, and that LST daytime cover in the daytime land surface temperature. Okay, then where to the access data, so how we can download the MODIS land surface temperature. Okay, so there is the different tools. Okay, so I am using to download the data NASA Earth data set. This is the very popular UGS Earth Explorer. Okay, and the NASA Earth data search, and here all the another tool also you can download by the any tool, okay, but very popular is NASA Earth Data Search and the USGS Earth Explorer, okay. So there is the some functionality of the data. So NASA Earth Data is why it is the very popular, because through the NASA Earth Data Search you can browse the image preview, direct download or order search subset, okay. Or here also browse image preview and search, okay. There is the description also. So let's know how to download the data, okay. Open the Google Chrome, okay. Search here, search Earth Data nasa.gov, okay. This is the URL, okay. Type here search.earthdata.nasa.gov. After open the Earth Data, then go to the login option, okay. To log in the Earth Data, NASA Earth Data, you have must have a account, okay. If you not have it, so very first quickly create a data to log in the data. Here also after click open the link, you need to log in the data, okay. So here also I am also login the Santonu, okay. So again after login the data, the mod is version 6 data, that is the MOD 11A1. Remember this data cover the land surface temperature, MOD 11A1, okay. Type here, okay. So the mod is Terra land surface temperature emissivity daily global 1 km sinusoidal grid version 6 data is available, okay. So now, so in this tutorial I want to calculate land surface temperature of the India capital over the Delhi boundary, okay. So search the your desired area or your the research area or your study area, okay. Then there is the spatiotemporal date of the I am using the 2020 month of June, okay. And to 2020 June, the 13 June, okay. So my data will be cover 1st June 2020 to 13 June 2020, okay. Then go to the apply, again go to the select the rectangle, okay, and just drag down. So now area will be covered, again enter and data will be appear, okay. So now click here the mod is Terra land surface temperature emissivity daily global 1 km version 6, okay. So click here, so after clicking the you have seen the data will be available, okay. So here is the data in 1st June 2020, 2nd June, okay, then 3rd, 5th, 4th, 6th, okay. So data also available. Then go to the download all option, okay. Then click here done and go to the download all data, okay. Click here download all data. So here is the mod is Terra land surface temperature emissivity daily global, matlab that means the data cover with the daily basis, okay. And the spatial resolution is 1 km and sinusoidal grid. So here is the data is available. So you can also download by the download script, and here also click the browse imagery, to open the zip file. Okay, go to the download files, click the layer, okay, link. So after clicking the layer, the download option is available. Okay, so go to the your download option folder. Here is my folder. Okay, so HDF data download here. So you can click the link one by one and download the data. I have already downloaded to so I have already downloaded the data. Is the HDF data, lots of data here. Total data is 13. Okay, so by the click the link, you can download easily one by one the data. Okay, so I have already downloaded the data. To process fastly, let's see how to calculate the land surface spatiotemporal analysis over a region. Okay, so at first add a single data. Okay, to know the data type, the data format is the HDF format. Okay, so here is my driver E and is the folder and spatiotemporal analysis and the HDF data, that means the input data. The data format is the HDF. Okay, so add. So here we can see in the previous presentation we have seen total layer is 12. Okay, so the sub data set ID, that is the 0, that contains the land surface temperature of the daily, and the sub data set 4, it is the variable, okay, that contains the land surface temperature of the night. Okay, this is the night time and this is the daytime. So 0 is the daytime land surface temperature and 4 is the nighttime land surface temperature. Okay, so after that, adding a shape file, we have cancelled to input the raster HDF file, because there is a magic to calculate the spatiotemporal analysis of land surface temperature. I have show you how to create a model, and through the model you can calculate automatically land surface temperature. Okay, automatically after 30 minutes you have calculated a lots of data, not a single data, more than 30 tiles. Okay, so let's start the model. Okay, so at first go to this is my the enter process work folder. Okay, go to the new, here click the toolbox, clicking here, rename the toolbox LST, land surface temperature. Okay, then go to the new and create the model. Okay, so model is open. Okay, at first go to the insert and go to the iterators and go to the raster, because if you want to calculate lots of data, okay, so you need to a iterator to calculate the entire data. Okay, you have seen my data is total 14 HDF file. Okay, then go to the click iterator raster and selecting the input folder. Okay, remember selecting only input folder. Okay, not a file. Then go to the data format. You have know the mod is provided in HDF format. Okay, so selected. After selecting the, so this is the, okay, so now go to the subset data, because the modis data is consist of 12 layer. Okay, so you need to, for daytime calculated, you need to only 0 layer. Okay, first layer. So type here extract sub data set. Okay, just click and drag down the model box. Okay, again input raster. Here input raster is modis 11.1a. Okay, selecting the raster and the sub data set id. Okay, for calculate the daytime land surface temperature you need to select 0. Okay, because 0 total layer is 12. Okay, so I am selecting the lst day 0. Okay, okay, then you need to click here and giving the a output folder. Okay, not name. Okay, giving a output folder. So create a folder, extract sub data. Okay, just giving a syntax of %sign name, close the %sign and the file format type, because we have, I am told you this is a magic, automatically all the process is done in automatically. Okay, so by typing this syntax the naming in automatically input. Again so at first we have insert iterated raster, then extract sub data set, then go to the search. Okay, and reproject raster, reproject raster, because sorry because the modis data in the sinusoidal projection. Okay, so you need to reproject the raster. So there is the projected raster. Okay, so after adding the raster, rename this. This is the sub data set. Okay, so here input the raster, this is the automatic sub data set. Okay, and giving the output coordinate system, I am selecting GCS WGS 1984. Also you have select your desired coordinate to reprojected UTM or GCS or any other projection. Okay, here again click here and select the creative folder, that is the reproject. Okay, reproject, again same adjective sub data set name, close this syntax dot tip. Okay, tip. Okay, so then rename this. This is the reproject raster. Okay, again after search raster calculator. Okay, using raster calculator facial analysis tool, because you need to convert the data in Kelvin to degree Celsius. Okay, we have seen also in previous slide the data will consist in Kelvin. Okay, so at first select the float. Okay, again go to the reproject raster, multiple by the scale factor 0.02, and we have no uh, 0 degree equal to 273.15 Kelvin. Okay, so remember it, float reproject raster into scale factor minus 273.15 Kelvin. Okay, so here is the main syntax. Okay, to convert the Kelvin to degree Celsius. Okay, at first the reprojected raster into scale factor minus the 273 minus 15 Kelvin. Okay, you have no 0 degree equal to 273.15 Kelvin. Okay, again go to the output. So create a folder, LST degree Celsius. Okay, again here type name dot tip. Okay, save. Okay, again rename. This is the LST degree Celsius. Okay, now search clip to clip the final output or your study area or entire region or region of interstate. Okay, so I am using clip data management tool. Okay, so we are using input raster as a LST degree Celsius. Okay, output your study area. I am using here Delhi boundary. Just check it. Okay, and okay, and save the output. Clip final. Okay, and type here same to process the automatically name. Okay, name dot tip. Okay, this syntax using the output name automatically. Input raster boundary. Okay, what is the problem? LST DC name dot tip. Save. Okay, output output raster dataset is same as input raster. Oh, sorry, the folder name is selected. In click the clip final. Okay, again shift name dot tip. Okay, so So entire model is ready. At first I am using the iterated raster, then extract sub data set to extract a single layer. Again projected raster, because it is the sinusoidal projection, you have need to reprojected. Again go to the raster calculator to convert Kelvin to degree Celsius and is the final clip. Okay. Then go to the model and save the model. Okay, so now is the magic. You have seen just 10 minutes, total 40 number of tile is process. Okay, I think nothing 10 minutes, I have seen the entire process over the screen. Okay, just so now starting in 11:01 p.m. Okay, let's see how much time is required to process the entire data. So you have seen processing every data. I have total data in this folder is total 14 tile. So you have seen process the, so just a 1 minute, remember just 1 minute I have processed the 14 tiles. This is the magic. Okay, just open the layer name and now opening the data. This is the magic. And so my final output is clip final. You can see here all data and automatically extracted. You have nothing, input the name. Okay, sorry, output the name. Here also you can see the extract sub data set automatically. Okay, and LSTDC automatically. So using the syntax you can using the data. So now let's see, open the all data. So entire data is open in degree Celsius. Okay, suppose one data in cloudy, so there is some problem. I removing this data. Okay, and all of the data in degree centigrade. Okay, just open one by one, turn all layer off, select here and go to the color option using this color and invert. Here invert means high represented in red and low represented in green. Okay, so you can see the red color represent the high temperature, the temperature here also. Okay, so here temperature in 36.47. here just selecting this layer, just a minute, 38, 34, 35. Okay, this is the 33 because presence of vegetation. Okay, vegetation control the temperature. Okay, again another data. Okay, so there also so through the process you can easily calculate the daytime land surface temperature. Okay, now again go to calculate the uh, night time land surface temperature. Okay, just rename the folder after uh, creating the a single first of the model. Okay, you need to just rename the folder. Okay, so again go to sub dataset. Okay, just rename the folder name. Okay, so here creating a new folder, that is the night l st. Okay, again creating a subfolder, that is the sub data set. Okay, again type here name dot tif. Okay, save. Okay, one thing remember, after that go to the Reproject Raster. Okay, create a subfolder Reproject Raster. Okay, shift syntax type here name dot tif. Okay, save. Okay, again go to the LST in degree Celsius, just change the subtype. This is the magic. LST EC night. Okay, save. Type here name and dot tif. Okay, save. Okay, again go here the final output. Again subfolder clip final data. Okay, clip final data. Again type name dot tif. Save. Okay, so after entering all the folder, now go to the data raster. Okay, again your input data is same folder, and just remember you have to change here. Okay, so now we have select the data type in 4, at first using 0 for the daytime and 9 time using 4. Okay, okay, this is the same HDF data, HDF format. Run magic, just a minute. Now open the night time data. So uh, this is the daytime. Day time dot tip. night time dot tip. Okay, so the daytime is high value is 41 and night time is 31. Now changing, here go to the effect, add effect button and add the where is the swipe tool, here is the flicker and here is the swipe. Okay, so changing the daytime, sorry, changing night time. So now you can see here daytime is high temperature and night time is very low temperature. Okay, because this is the emissivity, depend on the emissivity, and some of the region in consist there is a daytime in low and night time also low, because presence of vegetation, here also presence of vegetation, and this is the core region of Delhi and the build up area, no changing. So through the process you can easily identify spatiotemporal analysis of land surface temperature. Okay, in the below link section I have put the toolbox. Through the link you can easily download and process the data. So thank you everyone. If you like my video, please subscribe my channel and stay with me. Thank you. Bye bye. Have a good day.